Okay, we're going to talk about first and second differences and how they help us determine from our data what type of relationship we're looking at. So first and second differences is very common to set up a table. What I'm going to do is just give you a little overview of this first. First differences, if you find first differences between a set of data, and I'll give you just a quick set of data. Think of it like this. We have a bunch of coordinates, x and y. Maybe the first one, 0, 1, 1, 2, 2, 3. To find out what first differences would be, first we take a look at our independent variable, which is commonly known as the x value, okay? X, we gotta make sure it's changing by the same amount. And in this case, yeah, it's changing by +1 each time. Great, that works out. Then we check our y. We find differences, okay? So in other words, take a look at the change in this 2. What's this changing as? Well, if I take 2 and subtract 1, I end up at 1. Oh, that was hard for me for some reason. If I take 3, subtract 2, we end up at 1. The next value on here, if we went to 3, would actually end up being 4, and that would equal 1, 2. So our first differences, okay, would check out. They're all the same. That means we have a linear equation, okay? Which also means a linear equation, if you remember, is something like y is equal to mx plus b. And let's just use some variables here. In fact, can I get this one really quickly? Yeah, this actual equation would be this. That's the equation of this one here. I don't expect you to be able to see that right away. But what's important here is to notice the power. This is to the power of 1. So think of first differences means my variable of the highest exponent is to the power of 1. Second differences. Let's say we're talking about second differences. Same concept. We have a set of data, x and y. Again, we got to make sure our x's are going up by the same. So 0, 1, 2, 3, and we check it out. Yeah, these are all increasing by the same amount, so that checks out. We got to check our y values. I'm going to have to come up with some off the top of my head very quick. Okay. We take, the very first step is to take the first differences. So we do the same thing we did in the original, first diff. Okay. And we take a look. Well, 0 subtract 1, that gives me a value of 1. 4 subtract 1, that gives me a value of 3. 9 subtract 4, that gives me a value of 5. First differences did not check out, which means this is not a quadratic relationship. Okay. I take those first differences and I find the differences of them, hence the term second differences. 3 subtract 1, well, that gives me a value of 2. 5 subtract 3, that gives me a value of 2. If I were to have kept going, this would have been 4, 16, would have been 7, and 7 subtract 5 would have been 2. In this case, the second diff, that checked out. They're all the same, which means we have a quadratic relationship. If you remember quadratics, commonly written, ax squared plus bx plus c. The exact one I've actually happened to use is y is equal to x squared. I don't expect you to know that either, but what's important to notice again is because the second difference checked out, that means we have a variable of the highest power is 2 in this case. So what I'm going to do now is we're going to do a little bit of testing. We're going to create a scenario. So this is something we'd used before. I'm going to take this relationship, copy it, oops, and I'm going to put it in here, and I think I can turn it into a table real quick. Yes. So I hit the settings, and I have my relationship here. I'm going to click this button, convert to a table. Oh, it didn't give me that. That's okay. I'll just give me that. I think I can just type it in. Did not convert to a table nicely. Let's try this one more time. Why didn't it convert? Okay. I have too many functions of the firm f. I'm just going to call this y. Let's get rid of that. It's because I have more than one function defined as f at x, Nathan. That's kind of a no-no here. I'm just going to change this to y so that we're not running into that. And here we go. So we have some data. We're going to steal this data and run it through what we talked about before. So we'll get another page here. I'll set up our table just like we did before. Makes sense to use a tool for straight lines. Okay, we have our y. And -2, -1. Okay, so they gave us some values. You'll notice -2, -1, 0, 1, 2. Just as we talked about before, x values are increasing by the same amount. Perfect, that checks out. What about the y values? 64, 42. So 64, 42. 24, 10, 0. 24, 10, 0. Great. Let's run it through the gauntlet here. First differences. Okay. It doesn't actually matter if I start from the top and then subtract the second number, or if I start from the second number, subtract the first. I know in real subtraction that does make a difference. We're just looking for the change in each of the values. Is that change constant in the first differences? And just what you got to make sure is don't subtract from the top to this one and then from this one to that one. If you change the order you're subtracting, you will mess up the scenario. Because I happen to start at the second one and go up, I'm going to continue that pattern just so it makes a little sense here. 42 subtract 64 will give us a negative value, and it's going to give us 22, -22. Difference between 24 and 42, 18? I believe that's 18. -18. This is -10. I'm going to double check that one. I could be wrong. Oh, no, that's -14. What am I talking about? 10 subtract 24 is -14. And 0 subtract 10 is -10. Okay, first differences, they didn't check out. So let's do second differences. Let's take a look. 18 subtract 22. Subtract -22. It's going to be actually a positive value. 4. Okay. 14 subtract -18 is like the same as adding 18, gives you +4 again. And 10 subtract -14, the same as -10 plus 14, +4. Hey, second difference is checked out. That means we have a quadratic. We don't have the equation of it yet. And remember, I kind of cheated. I literally pulled a quadratic equation and got our data. So this is a way if you've just been giving data. And when we say data, think of it as these are coordinates. Each of these represents an x and a y value of some coordinate on a graph. Okay. Another way you could get a general idea. I mean, this is a very quantitative way to solve it. But let's say we're on a graph. We have -2, -1, 0, 1, and 2. I'll do my best to represent this well. Say 10, 20, 30, 40, 50, 60. At -2, we're at 64-ish. Here we're at 42. 1, 2, 3, 4. It's about here. 0's at 24. I think that's about there. 1 is at 10. 2 is at 0. I mean, not wonderful to tell, but we're starting to do a curve, which kind of tells you this isn't linear. But just because it curves, it doesn't mean it's quadratic either. There are something, I could find third differences, which gives me a cubic function. Fourth differences is a quartic function. So you do have to run it through this, but you can get a general idea of usually at this level, they're really just looking for linear, quadratic, or neither of them. Okay, so just keep that in mind when you're going through that.